Hi everyone, I want to take a moment to make a short video just reviewing a few of the properties we talked about yesterday and talking about a few other properties that are just true for math in general with real numbers, not specifically addition or multiplication, but properties we're going to use. So take a second, I want you to look at these properties and see if you can use your foldable or your notes to name them. And I'm going to pause this and when we come back, we're going to talk about them real quick. Okay, so let's go over these. Our first one is 0 plus 16. So which property is that? Well, it's addition. That's our first key there. And it's 0 plus 16 equals 16. So it's addition and everything stayed the same. The number stayed itself. So this is the additive identity property, okay? The additive identity. All right, our next one is 0 times A equals 0. 0 times A equals 0. And so anything times 0 is 0. That is our multiplication by 0 property, or the 0. You hear different ways 0 multiplication property works if you want to say it that way. Multiplication property. So basically, anything times 0 is 0. All right, negative b plus b equals 0. This one also is addition, so it lets you know that it is an additive property because there's addition in the actual problem. And we're adding b to negative b, and we get 0, so that's the additive inverse property. Our next property is a divided by b times b divided by a equals 1. This is multiplication, so it lets us know that we are using our multiplicative properties. Multiplicative, that's a mouthful, property. And this is the multiplicative inverse property. So a number multiplied by its inverse will always equal 1. Okay? Our next one is also multiplication. That lets us know it's another multiplicative property. And it's 1 times 7 equals 7. So it's anything times 1 is itself. So that's our multiplicative identity property. Identity. Very good. And then 9 times 0 equals 0. Again, that is our multiplication property of 0, or 0 multiplication property, depending on however you want to say it. Okay. 3 plus negative 3 equals 0. This is a repeat property. So this is, again, is addition. So it's our additive inverse property. A times 1 equals A is multiplication. So that's going to be our multiplicative, multiplicative identity again. And last but not least, 1/2 times 2 equals 1. That is another multiplicative inverse property because we are looking at that property and we are multiplying by the inverse, and so we end up with 1. So I don't have any examples of commutative and associative on here, but you understand the commutative is that the order does not matter, and associative is the grouping does not matter. I hope you were able to use your foldable and identify these on your own. We're going to quickly talk about just a couple other properties we see in math. The first one of these is called our reflexive property. And you can write these on the back of your foldable or in your notes. Reflexive property is any quantity is equal to itself. So A equals A, 5 equals 5, 4 plus 7 equals 4 plus 7. You use these properties a lot in geometry, and you need to think of it as like looking in a mirror. When you look in a mirror, exactly what you see is reflected back at you. That's how the reflexive property works, okay? Our next property that you will see in math, and again, these don't work for multiplication or addition. These are just true in general. So you could also use this example of like 4 minus 3 equals 4 minus 3. So these can involve subtraction and division. All right, our next property is the symmetric property, and that's if one quantity is equal to a second quantity, then the second quantity is equal to a first. So if A equals B, then B equals A. So reflexive is the same thing. Symmetric is able to kind of flip-flop two different things. So if you have 8 equals 2 plus 6, then you can say 2 plus 6 equals 8. You can flip-flop back and forth there. So the symmetric property, I have a picture of a butterfly up there because if you slice the butterfly in half, it's symmetrical on either side. It totally matches up and you see the same thing. So it's not like me saying 4 equals 4, kind of like me saying 4 equal, like this would be reflexive. 4 equals 4 is reflexive, okay? Symmetric would be like me saying 4 equals 2 squared, and then 2 squared equals 4. This would be symmetric, okay? So this is a symmetric property in math. And again, these don't have to just apply to addition and subtraction like the other ones, all right? All right, our next property we're going to talk about, and we don't have a lot, we just have 3 more after this, is the transitive property. And this property says if one quantity equals a second quantity, and the second quantity equals the third quantity, then the first quantity equals the third. We are going to use this a lot this year, this concept. And this concept basically is that if A equals B, B equals C, then we can say A equals C, okay? And we kind of use it, I kind of use the logic this way, all right? B equals B is the reflexive property, right? Well, I can then substitute and say, okay, if B equals A, I can put A in there. And if B equals C, I can put C in there. And that's how we derive that A equals C. So in this example, we have 6 plus 9 equals 3 plus 12. And 3 plus 12 equals 15. So we can say that 6 plus 9 equals 15 because they both share the same thing that they're both equal to. So they both are equal to 3 plus 12. In math or in algebra, we use this a lot with if x equals y and y equals 8, then we can say x equals 8. So if children equals future and future equals robots, then children equals robots. That's kind of like it with silly words. But the transitive property is very, very useful in math because we can use this property all the time in situations like this where we don't know what something is, but if it's equal to something else and we do know what that is, then we can replace it. And then the last property we're gonna, we have 2 more. The next one we're gonna do is the substitution property. And this is basically saying is a quantity must be substituted for its equal in any expression. Y'all can think of this with sports and substitutions. When a team substitutes in a player, they're not gonna just substitute in like a random person. They're substituting in another person that's equally qualified to be in that position. So if A equals B, then A may be replaced for B in any equation. So in this example, if n equals 1, n equals 11, then, and we have 4 times n, we can take 11 and we can substitute that in for n right here to get 4 times 11, okay? So we use this property a ton in math. In fact, this property is basically the concept of solving equations, is that we put this variable, we substitute this variable in for this unknown quantity we don't know yet. And the last property we see with math is distributive property. And we have talked about this and we will keep talking about this. The distributive property basically says that if you have A on the quantity of B plus C, that's equal to A times B plus A times C. And the same thing with A on the quantity of B minus C is equal to A times B minus A times C. So our example here is that we have 5 times 4 plus 2. So we know that's 5 times 6, which is 30. But we could also do it this way. We could say, okay, 5 times 4 is 20, and 5 times 2 is 10. 20 plus 10 is 30. So it means the same thing. You can do it with numbers or with minus 2. The reason we use this a lot in algebra is that if we have situations like this, we can't add up 4 or x plus 2. So you have to use that concept of 5 times the x plus 5 times the 2 is 5x plus 10. So we're going to use that distributive property a lot in the weeks to come. The big thing to remember is that you have to give it to everybody inside of the parentheses. You have to give it to the 5, and you have to give it to the 3. And these creepy little children have 5 and 3 for their face. But those are the main properties we're going to use. These last 5 properties we use all throughout math for the rest of your math career. In fact, all these properties we use throughout math. But the last 5 we talked about are applicable in more than just multiplying and addition, okay? So please keep that in mind. I'm going to post this with this PowerPoint if you need to look at it. Have a great day. Use today to get caught up on any missing work, and I will see you guys on Monday. Goodbye, everybody.